A year ago, running a 1 trillion parameter model meant renting a data center space or getting the most expensive hardware H100, somebody controlling rate limits. Today, it fits on your desk. Doing AI inferencing locally is no longer a hobbyist thing. Today, it's very much possible thanks to machines like this. No API limits, no rate limits, the model just running on your computer the way you want it. Now, before we get into details, let's talk about what's exactly in this machine. The CPU is a 9960X built for workstation class loads, paired with 128GB of DDR5 RAM running at 5400 MHz. The RAM matters more than you think, and we'll come back to that. The GPUs are two RTX 6000 Pro Blackwell Max-Q editions. Now, the reason not to go for the workstation class card is this actually consumes 600 watts of lesser power, 300 on each card. So both of these are Max-Q cards which run at 300 watt TDP. They both have the same 96GB VRAM, all the specs are the same memory bandwidth, the same memory bus, but requiring 300 watts of lesser power. Now here's why it matters for a multi-GPU build. Two Max-Q cards keep you at 600 watt of total power draw with just about 11 to 12% of compute loss. I think that's a decent trade-off if you're spending 600 watt less on this kind of build. And since this is for inferencing, you're not actually giving up anything major, because inferencing is not bound by the power you consume, it's actually depending on memory bandwidth. So on a desktop class machine, the Max-Q is absolutely the right call. Save memory, don't lose anything on inferencing, bingo. Now most people in this space have at one point hit that VRAM limit. You want to run a serious model, you look at the VRAM requirement and you hit a wall. And the workarounds usually mean that the model throughput is kind of degrading because you're fine-tuning things out which actually hurt the model performance or the model output itself. Now two cards at 96GB VRAM, a total of 192GB VRAM. Now this moves the limit so far ahead that most open weight models don't even come close. Kuch bhi chalega bro is pe. Almost kuch bhi. Tools like LM Studio also allow you to offload the model context to the system memory. That is why the system has 128GB of DDR5 RAM. ऐसे ही नहीं लगाते लोग. Now we maxed out the context window for each model we tested with full GPU offload, and yes, there was simply no CPU leakage. Now the first model we tried was Qwen3 Coder Next, which is an 80 billion parameter model. Now VRAM load across both cards was 29.3GB on one, 28.1 on the other. Both cards drawing about 250 watt, generating about 140 to 155 tokens per second. So despite the 80 billion headline, it's only activating 3 billion parameters per token during inference. That's what makes this speed possible. Time to first token 3.77 milliseconds, decode speed 140 to 105 tokens per second. For anything under 100 billion parameters, you could honestly run this on a single card and it would still feel instant. Now this actually brings us trying to run some models which actually stress this system. Now first up was DeepSeek. Now DeepSeek R1 distills 70 billion, full native quant, no compression tricks. Now the VRAM load was 48GB on one card and 50GB on the other. It's nearly one full card worth of VRAM being utilized. Now the time to first token for this was 0.58 seconds. Decode speed of 25 to 30 tokens per second, which is actually not bad. It's as good as trying to chat with ChatGPT. Now there's a straightforward reason why this is much slower. Now DeepSeek R1 is a dense model, which means every single one of those 70 billion parameters is active on every token. What this means is the activation pattern actually matters more than the parameter count. For example, we also run the GPT OSS 120 billion parameter model. This model is built on a MOE architecture. So it has 120 billion parameters in total, but only a fraction are active per token. It used about 38GB on one card and 35 on the other, with the insane token speed of 175 to 180 tokens per second. So it's lighter than DeepSeek despite being 50 billion parameters more, just because of MOE. Now the time for first token in GPT OSS was 0.6 seconds. What's worth noting is across each of these tests, we kind of maxed out the context window every time. And that's exactly why you saw the RAM being pulled into the picture. The system was using RAM for context cache, while the model weights stayed on the GPU. But for most real workloads, you probably wouldn't push context so hard. So yeah, if your workload can be done on an MOE architecture model, you probably don't need this amount of VRAM. Now inference is obviously just half the story. There's a lot more that can be achieved with this kind of a system. Fine-tuning a 7 to 13 billion parameter model is possible with just one of these cards, just one. With two, you're kind of getting into the territory which required you to rent a cluster a few months/years back. So yeah, इस पे सब कुछ हो जाएगा bro, सब कुछ. Now this build makes maximum sense for people who are dealing with sensitive data. They don't really want to share their data, put it up on a cloud, and are struggling, rather dealing with high cloud costs and API bills. This also makes sense for AI startups which have low latency requirements and actually are frustrated with their cloud bills already. On-prem is actually worth it in more ways than one. If you like this video, do comment. We have even more crazy builds like this coming up. Do let us know what you'd like to see us test on this. Peace.